All right, so you're gearing up for your next big project, and you hit a wall.
Oh, yeah.
Which database should you even use?
Yeah.
It's almost like you're standing in the cereal aisle,
Right.
completely overwhelmed by options, but you
Right.
really just need a bowl of that data crunching goodness.
Right.
So in this deep dive, we are tackling a database performance showdown,
Ooh.
and we're focusing on one question. How fast can these databases insert data?
That's a good question.
Yeah, because that could really make or break your project, especially when we're talking about lots of data.
Oh, absolutely. When you're dealing with tons of data, that can really be a bottleneck.
So we're going to be putting PostgreSQL, MySQL, and SQLite through their paces.
Okay. Love it.
We're going to challenge them to insert 1,000 rows.
Right.
And we're going to see what happens.
So it's like a database drag race.
We love that.
But instead of looking at these flashy cars, we're going to look at the engine under the hood
Yeah.
and really see, okay, how does each database handle this fundamental task?
I love that analogy. And
Yeah.
we're not just going to be clocking their speed right.
Right.
We want to know why.
Yeah.
We're digging into the why behind the numbers.
Absolutely.
And we're going to be thinking about things like transaction management, concurrency, and network overhead.
Right.
All of those things that we don't see.
Behind the scenes.
Exactly, the behind-the-scenes factors that reveal the strengths and the trade-offs of each of these databases.
And you can make the best decision.
So by the end of this, you'll understand what makes them tick,
Right.
what makes these databases tick, and which one's the best fit for your project.
Okay. Sounds good.
So before we get into the results, let's introduce the contestants.
All right.
Okay, so first up, we've got PostgreSQL.
This is the workhorse.
Yeah, the reliable workhorse.
Known for data integrity,
Hmm.
really being able to handle complex queries.
It's like the Fort Knox
Yeah.
of databases.
Making sure your data is safe and sound.
Next, we have MySQL.
This is a popular option
Yes, very popular.
for web applications, known for its speed and its reliability and ease of use.
Yeah, I would agree with all of those.
So think of it as a well-rounded athlete,
Yeah,
good at a lot of things, and just ready to go.
ready to hit the ground running.
Yep.
And finally, we've got SQLite.
The lightweight champ.
Yes, this is our lightweight champ.
Perfect for smaller projects and environments where resources are limited.
Right, so we're thinking mobile apps, embedded systems, or anything that needs to be nimble and efficient.
Yeah, that's a great way to put it.
Okay, so we've got our contenders lined up.
Awesome.
Now, to make this race a little more interesting,
Okay.
we're throwing down two challenges.
I like it.
Single inserts,
Okay.
where each row is added one by one,
All right.
and bulk inserts, where we're trying to cram all 1,000 rows in as part of a single transaction.
Okay, so we're really testing these different workloads.
Exactly, and that's going to be really crucial because we'll be able to see how each database handles those different workloads.
Yeah, like single inserts, that would be like adding items to an online shopping cart,
Yeah, one at a time.
one at a time.
Okay.
But bulk inserts, that's more like if you upload a massive spreadsheet
Yeah, all at once.
all at once.
And this is where things get really interesting.
Okay.
So in the single insert challenge, SQLite blew everybody away.
Really?
It zipped through those 1,000 rows
Yeah.
in about 2,000 milliseconds.
Wow, that's significantly faster than PostgreSQL and MySQL.
I was expecting SQLite to be quick, but
Yeah.
I mean, come on. PostgreSQL and MySQL, they're often touted for their speed,
Right.
but SQLite just showed them who's boss.
Yeah, and this is where understanding the why behind the numbers is really important.
Totally.
Remember, SQLite operates directly on a file,
Okay.
unlike PostgreSQL and MySQL, which rely on that client-server setup.
Right.
So that means SQLite doesn't have the overhead of communicating over a network,
Got it.
which makes it lightning fast for these types of operations.
So it's like having that local shop right around the corner. You
Yeah,
can just pop in, grab what you need.
exactly.
No waiting for delivery.
You got
When we switch gears to bulk inserts, SQLite maintained its lead,
Okay.
and it finished in a mind-blowing 15 milliseconds.
15 milliseconds.
15 milliseconds.
Wow.
It's like it blinked and it was done.
Yeah.
So I guess this really highlights the advantage of SQLite's lightweight file-based approach
Right.
when it comes to raw insert speed, especially in a controlled environment like this.
Absolutely. But remember, there's more to the story than just raw speed.
Okay.
Let's look at how our other contenders handled this bulk insert challenge.
Right.
So PostgreSQL, with its emphasis on data integrity and those super strict ACD properties, it completed the task in about 100 milliseconds.
Okay, so not quite as lightning fast as SQLite,
Right.
but still a pretty solid performance.
Definitely. And what's really interesting here is the dramatic difference
Yeah.
between PostgreSQL single insert and bulk insert times.
Totally right,
Yeah.
because remember, it took over 5,000 milliseconds for those single inserts.
That's right.
So what's the takeaway here?
Well, is PostgreSQL just slow?
Yeah, is it just slow?
Not necessarily. It's more about how PostgreSQL prioritizes data integrity above all else.
Right.
So it's like having this meticulous accountant
Okay.
who carefully checks every penny before recording it in the ledger.
Yeah, like that.
This attention to detail ensures that your data is always consistent and accurate.
Makes sense.
But it does add some overhead, especially for those individual inserts.
Okay, that makes total sense. I mean, so it's really taking those extra precautions to make sure everything is perfect. But, I mean, isn't that a good thing?
Yeah, I mean, who wants their data to be corrupted
Right.
or inconsistent?
Yeah.
But like you said, there's always a trade-off,
Yeah.
right?
Okay.
PostgreSQL's strictness comes at a performance cost,
Okay.
especially for those individual inserts.
So it's kind of like choosing between the meticulous accountant who takes their time to ensure accuracy,
Right?
and then you've got the speedier cashier who might be a little less thorough.
Yeah, that's a great way to put it.
It all depends on what's important to you in that moment.
Yeah, and that's why understanding your project needs is crucial. If
Right.
you're dealing with financial transactions or sensitive data where absolute accuracy is non-negotiable,
Right.
then PostgreSQL's robustness is invaluable.
Yeah, but if you're working on a project where speed is king
Right.
and the data is less critical, you might want to consider a different approach.
Makes sense.
So speaking of different approaches, how do SQLite and MySQL handle transactions?
Well, SQLite, with its focus on simplicity and efficiency, takes a more streamlined approach.
Okay.
It still supports transactions,
Mm-hmm.
but they're much more lightweight compared to PostgreSQL.
Okay.
So it makes it lightning fast for simple inserts, but it might not be the ideal choice for applications that require those ironclad guarantees
Of the ACD properties.
of AC properties. Exactly.
So it's like choosing between the high security vault for your prized possessions
Right.
and then a simple lockbox for everyday items.
Yeah, I like that analogy a lot.
And then we've got MySQL.
Right. MySQL sits somewhere in between. It supports ACID properties,
Mm-hmm.
but it offers different transaction isolation levels.
Okay.
So it gives you more flexibility to fine-tune that balance between performance and data integrity.
So transaction isolation levels.
Yeah.
Is that something our listener really needs to worry about?
It depends.
Okay.
It really depends on the project.
Okay.
But basically, isolation levels determine how much a transaction is isolated
Okay.
from other concurrent transactions.
Okay.
So higher isolation levels provide stronger guarantees of that data consistency,
Mm-hmm.
but it can introduce more locking, and that can potentially slow things down.
Right.
Lower isolation levels are going to be more performant,
Okay.
but you might allow for some minor inconsistencies.
Okay.
But that's only in certain edge cases.
Got it. So it's like choosing how much separation you need between different processes.
That's a great way to think about it, yeah.
More separation equals more consistency, but slower performance, less separation means more speed, but a little bit of a higher risk of conflict.
Exactly. So choosing the right isolation level really depends on the needs of your application.
Okay.
If you're building a banking system where even the tiniest inconsistency could be catastrophic,
Right.
you're going to go for the highest isolation level.
Of course.
But if you're building a social media app where occasional minor inconsistencies are acceptable,
Yeah.
you might opt for a lower isolation level
Okay.
to prioritize speed and responsiveness.
Got it. So MySQL gives you that control
Yeah.
to fine-tune those settings.
Right.
So we've talked about transaction management.
Yeah.
We've talked about concurrency. What other performance factors should our listener be aware of?
Well, that's a great question.
So we've seen SQLite just dominate in our speed tests.
Right.
But like we've mentioned, there's always more to the story
Yeah.
than just looking at the raw numbers.
Absolutely.
So it's time to unpack some of those behind-the-scenes factors that can make a huge difference
Right.
in choosing the right database.
Exactly. It's like comparing a cheetah to a horse.
Okay.
Both are fast, but one excels at those short bursts,
Right.
and the other is really built for endurance.
Yeah.
So we need to understand what each database is optimized for.
I'm particularly curious about this whole transaction management thing.
Yeah.
What exactly does that mean,
Okay.
and how does it impact performance?
So imagine you're transferring money between bank accounts.
Okay.
You want to make sure that both the withdrawal and the deposit happen successfully.
Right. Of course.
Otherwise, you've got money vanishing into thin air.
That's not good.
That's where transactions come in.
Okay. I'm seeing the analogy.
Yeah.
But how does this relate to databases?
So in a database, a transaction is a sequence of operations that are treated as a single unit.
Okay.
It ensures that all of the operations are completed successfully, or none of them are.
Right.
And this is crucial for maintaining that data integrity and consistency.
So it's like having a safety net to make
Uh-huh.
sure your data doesn't get all messed up if something goes wrong. Makes sense.
Yeah.
How does this tie back to our database drag race?
Okay, well, remember how we mentioned PostgreSQL being like the Fort Knox of databases?
Yes.
That's because it adheres very strictly
Okay.
to something called ACID properties.
Okay. ACE properties. That sounds intense.
It stands for atomicity, consistency, isolation, and durability.
Okay.
These are the 4 pillars of reliable transaction management.
Mm-hmm.
Atomicity ensures that a transaction is treated as a single unit.
Okay.
Consistency guarantees that the database remains in a valid state
Okay.
after a transaction.
Got it.
Isolation prevents conflicts between those concurrent transactions.
Hmm.
And then durability makes sure that once a transaction is committed, the changes are permanent,
Right.
even if the system crashes.
Wow. Okay. That's a lot to unpack, but I can definitely see how this could affect performance.
Exactly. PostgreSQL's commitment to these ACD properties means it's going to take a more cautious approach to transactions,
Okay.
especially for single inserts. So each insert needs to be validated, logged, and written to disk in a way that ensures data integrity.
Okay.
So think of it like a super careful banker
Yeah.
who double checks every single penny
Yeah.
before recording it into the ledger.
Got it. And that explains why it took so long to complete that single insert test.
Right.
It's like taking all those extra precautions to make sure everything is perfect.
Yeah.
But isn't that a good thing?
Well, I mean, who wants their data to be corrupted?
Right.
You're absolutely right. Data integrity is paramount.
Yeah.
But there's always a trade-off.
Yeah.
PostgreSQL's strictness comes at a performance cost,
Right.
especially for individual inserts.
So it's like choosing between that meticulous accountant who takes their time to ensure accuracy
Right.
versus a speedier cashier who may be a little less thorough.
Yeah, that's a great way to put it.
It all just depends on what's more important to you in that moment.
And that's why understanding your project needs is so crucial. So if you're dealing with financial transactions or sensitive data where absolute accuracy is non-negotiable,
Right.
PostgreSQL's robustness is invaluable.
But if you're working on a project where speed is king and the data is less critical,
Yeah,
you might want to consider a different approach.
makes sense.
Speaking of different approaches,
Yeah.
how do SQLite and MySQL handle transactions?
Okay, so SQLite, with its focus on simplicity and efficiency, takes a more streamlined approach.
Okay.
It still supports transactions, but they're much more lightweight compared to PostgreSQL.
Okay.
So it makes it lightning fast for their simple inserts,
Right.
but might not be the best choice for applications that require the ironclad guarantees of ACD properties.
Right. So it's like choosing between a high security vault for your most prized possession
Okay, yeah.
and then just a simple lockbox for your everyday items.
Exactly.
Okay. And then MySQL kind of, where's that one fit in?
So MySQL sits somewhere in between.
Okay.
It supports ACD properties, but it offers different transaction isolation levels.
Okay.
So it gives you that flexibility to really fine-tune the balance between performance and data integrity.
Transaction isolation levels. Is that something our listener needs to worry about?
It depends.
Okay.
It depends on the project.
Okay.
But basically, isolation levels determine how much a transaction is isolated from other concurrent transactions.
Okay.
So higher isolation levels provide stronger guarantees of data consistency, but can introduce more locking, which could potentially slow things down.
Right.
Lower isolation levels are more performant, but you might allow for some minor inconsistencies, but only in certain edge cases.
So it's kind of like choosing how much separation you need between different processes
Yeah, that's a great way to think about it.
happening in the database at the same time.
Yeah,
So more separation,
yeah,
more consistency, but potentially slower performance.
right.
Less separation, more speed, but a slightly higher risk of conflicts.
Exactly. Choosing the right isolation level really depends on the specific needs of your application.
Right.
So if you're building a banking system where even the tiniest inconsistency could be catastrophic,
Of course.
you're going to go for the highest isolation level.
Right.
But if you're building a social media app where those occasional minor inconsistencies are acceptable,
Right.
you might opt for a lower isolation level to really prioritize that speed and responsiveness.
So MySQL gives you that control
Exactly.
to fine-tune those settings based on your project's needs.
Yeah,
Okay, so we've talked about transaction management, we've talked about concurrency.
right.
What other performance factors should our listener be aware of?
Well, we've got to talk about network overhead.
So we've really explored a lot of the inner workings of these databases,
Yeah.
from how they manage those transactions to how they handle a bunch of users.
Right.
It's like we've taken a crash course in
Yeah.
database mechanics.
Absolutely.
We've seen SQLite's impressive speed,
Yeah.
PostgreSQL's commitment to data integrity,
Right. Right.
and MySQL's versatility.
Yeah, it really does a lot of things pretty well.
But now comes the big question, which one is right for you?
Well, at the end of the day, it's not about finding the one champion.
Right.
It's about choosing the right tool for the job.
So let's help our listener figure out which database is best for their project.
Okay, sounds good.
So let's start with SQLite, our speed demon.
Right.
Its simplicity and that file-based nature makes it really fast for inserts,
Yeah.
especially when you're working on smaller projects
Right.
or in environments where resources are limited.
Absolutely.
So if you're building a mobile app,
Okay.
simple data logger, or an embedded system,
Mm-hmm.
SQLite could be a perfect match for you.
It's like having a nimble scooter that just zips through traffic.
Yes, exactly.
With ease.
But remember, SQLite's strength is in its simplicity.
Right.
It's not really meant for heavy traffic
Yeah.
or complex multi-user scenarios.
Exactly.
It's not going to win any marathons.
Right.
So if you're expecting a ton of users hitting your database at the same time or dealing with those complex transactions that require absolute data integrity,
Yeah.
you might want to consider other options.
Makes sense.
And that brings us to MySQL, our reliable all-rounder.
Our Swiss Army knife.
Yes, our Swiss Army knife.
It's always ready to tackle a variety of tasks.
Always ready to go.
Yeah. MySQL has solid performance for both single and bulk inserts.
Yeah.
And those flexible transaction isolation levels give you more control over the trade-offs between speed and data integrity.
And don't forget that MySQL has a really large community,
Right.
and there are so many resources available.
Lots of documentation.
Exactly.
It's easy to learn.
Yeah, so if you're looking for a database that's really well documented, easy to learn, and has a ton of support, MySQL is a strong contender.
Yeah, I would agree with that.
So if you're building a website or a web app or any project that needs a good mix of speed, reliability, and ease of use, MySQL is a good one.
Yeah, definitely.
And last but not least, PostgreSQL, our champion of data integrity. While it might not be the fastest for those one-off inserts,
Right.
its strength is in handling those large batches of data
Yeah.
within a transaction. And it just makes sure every bit of information is consistent and accurate.
It's like that super secure bank vault.
Right.
Maybe not the quickest to access, but you can be sure your valuables are safe and sound.
Exactly.
Yeah.
So think financial applications, healthcare systems, anything where accuracy and reliability are really non-negotiable.
Yeah, you can't mess around with that stuff.
But before our listener rushes off to download their database of choice, I think it's really important to remember that we've only focused on one aspect of database performance.
Right. We've only talked about inserts.
Yeah, and there's so many other database operations to think about.
Yeah.
And they all have different performance considerations.
All
We
right.
didn't even get into reading data,
Right.
which is so important.
Just as important, if not more important.
That's a whole other deep dive.
Yeah, we'll say that for next time.
But for now, I think we've given our listener a solid foundation for understanding the differences between these three databases.
Yeah, definitely.
We've explored their strengths, their weaknesses, and the factors that influence their performance.
Absolutely.
So the takeaway here is choosing the right database.
Yeah.
Is all about understanding what your project needs and what your priorities are.
Yeah, figure out what's important for your specific use case.
And there's no one-size-fits-all.
Nope.
So to our listeners out there,
Yeah.
we encourage you to take this knowledge experiment with these different databases and see how they perform with your own workload.
Absolutely.
And don't be afraid to ask for help.
Yeah.
There's so much information available online.
So many resources out there.
Yeah, there are so many thriving communities for each of these databases where you can connect with other users and get your questions answered.
Absolutely.
Remember, choosing a database is just the beginning
Right.
of your data-driven journey.
It's a long and interesting road.
So go out there, build something amazing,
Yeah.
and most importantly,
Have fun.
have fun.